Assalamualaikum, my name is Muhammad Ahmad bin Sarwiyah Junid. I'm the author for this project. Now I will be presenting about our project 2D OCDMA encoder or decoder for various industrial applications. Okay, as we know, the optical network nowadays is expected to provide the variety of broadband service to the customer. Okay, the network must require an increase of bandwidth as well as the throughput. So the OCDMA system can increase the number of transmission capacity, as you can see in the figure 1, which shows the illustration of OCDMA system. OLT is optical line transmission, while ONU is optical network unit. The transmission can be classified as the voice, image, or video, and transferred through the fiber optics, then split to the receiver. Okay, our objective is to study various 2D optical CDMA codes with their properties. We also develop and design the 2D OCDMA encoder and decoder. We also analyze the performance of 2D OCDMA system, and we also implement the hardware or the hardware design by using the FPGA. So our aims and motivation. The communication system is getting more attractive, which demands for high-speed data transmission and encrypted communications. The development of the new optical CDMA 2D codes is to overcome the disadvantages of the existing codes. The aim of this project is to develop the new 2D OCDMA encoder or decoder for highly secure transmission. For the problem statement, the existing communications such as TDMA, WDMA has their limitation and drawbacks in terms of quality of service, decrease due to the number of users, high noise in information signals, lacks of bandwidth spaces, and also the 1D OCDMA codes require a long code length for increased cardinality, which means the number of simultaneous users. The solution for the problem is we apply 2D FCC MDW codes which enhance the flexibility of the code design and improve the performance of the system. In this slide, it shows 3 types of multiple access techniques, which is TDMA, WDMA, and lastly OCDMA. In TDMA, each user is allocated by a time slot. The problem of using TDMA is that once the number of user increase, it will cause a significant delay that will affect the performance of the system. While WDMA use wavelength for data transmission, but the problem with WDMA is it has a channel crosstalk, and the system is expensive due to using optical laser source for transmission. OCDMA use code to transmit data. By using code, it can be sent at any time without a collision. In this project, we will introduce OCDMA system with FPGA as a code generator. These are the board that we use for our project. FPGA DE1 SoC, developed by Intel. Now I will explain the various applications for 2D OCDMA system. Firstly, the automotive. One of the applications includes the implementation in automotive industry. For example, recent development requires multiple sensors to be implemented in a car. By using OCDMA, we can reduce the use of copper wire, which will decrease the amount of EMI because we use optical fiber. Each code can be represented as a sensor. This will also increase the speed of transmission because shorter fiber wire lengths can be used. In aviation, the OCDMA offers a high-speed internet connection for passengers. As we know, it can also decrease the use of copper wire, which will decrease the amount of EMI. Fast train can also offer high-speed internet connection for passengers, which is the same as aviation application. For oil and gas, the purpose is to decrease the risk of faulty wire, which can cause the fire outbreak in the facilities. When a spark occurred at the facilities, the oil and gas can be ignited due to excessive usage of copper wire. By using optical fiber, the amount of copper wire can be decreased significantly. In terms of communications, the data transmission can be enhanced with better communication signal. It can also increase the workplace safety measures. For the methodology, the basic idea of 2D signature code is to spread both time and wavelength domain, while 1D code can spread either time or the wavelength. So three main goals to achieve in designing the OCDMA system are good correlation properties, the elimination of multiple access interference (MAI), and good code cardinality with satisfactory performance. These are the code construction for 2D SEC MDW code. 2D SEC MDW is the combination of 1D SEC 1D flexible cross correlation code (FCC) and 1D modified double weight code (MDW). In OCDMA, code play a very important role. The performance of OCDMA system is depend on the code structure. OCDMA system can be either 1D or 2D code. Nowadays, the most popular technique of OCDMA is using 2D code. The table shows the basic code construction for 2D SEC MDW. Based on the table, each column represented by wavelength, while each row represented by times. For system design, our system consists of transmitter and receiver. As we can see in figure 4, the LED encoder and modulator can be classified as the transmitter, while decoder can be classified as receiver. Optical switch is used in transmitter and receiver, where it receives the code from FPGA. This is our design using the OptiSystem software. The version used in this project is version 11 for OptiSystem. As you can see here, we use the coupler instead of using optical switch. In practical, we use the optical switch which receives the code from the FPGA. The code generated using FPGA is shown in figure 6 and 7, which use 50 MHz as a clock signal. These clock signals are used to determine the switching speed of the optical switch for data transmission. The FPGA is used to enhance the performance of data transmission with its massive parallel processing, fast and efficient system, and ideal for real-time applications. Here are 2D OCDMA system performance. The performance of 2D OCDMA system is based on the output of receiver bit error rate. BER, bit error rate obtained in the opti system in the simulation has passed the minimum value of 10 to the power of negative 9. The BER obtained for the first receiver is 9.78436 times to 10 to the power of negative 42, with the value of Q factor for the first receiver is 13.4795. Q factor is an important parameter which determines the reliability of the communication. Q factor must be greater than 6 for error-free optical communications. Figure 8 shows the eye diagram for the receiver, while figure 9 shows the Q factor versus time. Okay, this is the graphical representation for 2D OCDMA system performance. The wavelength is represented by M, while the time is represented by N. This graph BER versus the number of simultaneous users. In figure 10, the number of time spreading is fixed into 4, while it has a different number for the wavelength spreading. For figure 11, the number of wavelength spreading is fixed into 18, while it has a different number of time spreading. As you can see here, as the number of wavelength spreading increase, the number of simultaneous users supported also increase. For figure 11, where the number of time spreading increase, the number of simultaneous users supported also increase. As you can see, while increasing the number of time spreading has a greater impact rather than the increased number of wavelength spreading. When the number of time spreading increase, it can support much more simultaneous users, such as 350 simultaneous users, while the number of wavelength spreading has lower number of simultaneous users rather than the number of time spread rather than the increase of time spreading. Here are the number of BR against the number of simultaneous users compared between 2D and 1D OCDMA. Figure 12 shows the number of simultaneous users for 2D SCC MDW, 1D SCC and 1D MDW. As you can see, 2D SCC MDW has the wavelength spreading is equal to 9, while the time spreading is equal to 4. The time spreading is fixed as the wavelength for SCC and MDW, which is W equals to 4, the wavelength. As you can see, based on this graph, 2D SCC MDW can support much more simultaneous users rather than 1D SCC and 1D MDW. It has a slight differences. This is because the number of time spreading is fixed into 4, which is the same as the wavelength for the SCC MDW. It can support much more Here are the prototype testing. The system is tested in 155 and 320 megabit per second, which obtained the eye pattern shown in figure 14. The BR is almost equals to 0. The code is supplied to optical switch, which presents an encoder and decoder in figure 13. As a conclusion, in OCDMA system, each user is assigned with a sequence of code that serves as its address. An OCDMA user modulates its code or address with each data bit and asynchronously initiates transmission. The advantages of CDMA techniques over other multiple access are numerous. The 2D OCDMA can overcome the problem faced in 1D OCDMA code. When we use FPGA as a code generator, the transmission data speed has been increased. The increase in time spreading has a greater impact on the enhancement of the system's schedulability than increase in the number of wavelengths. It's shown in the graphical representation before. And thank you for your attention.